Hello, my name is Steven. Welcome to HiFinder Tech Talk. In this series, we focus on understanding the technology that makes the hydrogen economy work. Gas, purity, and moisture are very important aspects when you are trying to build together things in the hydrogen economy. So that's why today I'm particularly pleased to welcome a guest who knows all about this. He's worked in spectroscopy. He's built up several companies also around the measuring area, now works at Parametrics. Alexander Trojanowski, welcome.
Hello, Steven.
Good to have you today.
Nice being here, and thanks for the introduction and the opportunity to present the products.
Well, yes, we will be interested to know what they are because I see you brought some with. Can you tell us very briefly what we see here?
Well, I have three products today with me. This is a binary gas analyzer. It measures percent level concentrations of one gas in another gas. Mm-hmm. Then I have a moisture transmitter, measures very low moisture content.
Okay.
And then I have an oxygen analyzer. It measures oxygen concentrations in different ranges and in different gases.
Okay.
As a background gas when we talk about that.
Okay. So yes, I mean, obviously these are important elements. Maybe can you take us through where would we find these in
well,
hydrogen?
now related to this topic, to the topic of hydrogen production by using electrolysis, these products are basically standing for representing our contribution to the process efficiency with the binary gas analyzer and the final product quality with the moisture and the oxygen analyzer. With the moisture and oxygen, we would measure the purity.
Yeah. Okay, but where in the chain would that be? So where would you be measuring?
This one is right after we split the water into hydrogen and oxygen.
Okay.
Like if you look at the drawing, just to illustrate better, electrolysis.
We have a diagram here. Mm-hmm.
Yeah, it's actually we're converting electrical power to hydrogen.
Yes.
To chemical power. Hydrogen is the energy carrier. Mm-hmm. After that, but you can see on the anode on the left side, the plus. That's the side where we create the oxygen.
Yes.
And the hydrogen will be produced on the cathode.
On this side, yeah.
Between those two, you have the membrane. Now, independently of what kind of electrolysis we talk, there will be a membrane there. In this case, based on how the plus and minus are, we talk here about the PEM method, the proton exchange membrane. So by the word proton exchange membrane, we understand that this membrane should allow only the exchange of protons, but it should prevent the gases from mixing. So if this membrane does not work well, there is a leakage or something has happened with the membrane. Then from the hydrogen side to the oxygen side, we might get some leakage, some crossovers. And the mixture between oxygen and hydrogen is pretty explosive mixture, especially if we are close to the explosive range, to the flammable ranges. You know, every gas, flammable gas or vapor, when within the concentration ranges that are declared, like within the low explosive level or upper explosion level, it will burn when in presence of oxygen. And the low explosive level for hydrogen, we talk here about 4%.
So when we look at the diagram, this one will then be on where? Will it be in there?
Just
or
right after the electrolyzer.
So on the outlet here, on the hydrogen outlet essentially.
On both sides,
on
basically.
On both sides,
because here we're measuring on the left side where the oxygen is. We're measuring that the hydrogen is not above the low explosion level. And on the outlet, we're measuring that the hydrogen is not underneath the upper explosion level.
And then you go further down the line here?
And further down the line, we have some purification steps. You can see the dryer is there.
Yes.
We have the oxygen. The oxygen will give you an indication of how should I set the specifications on the dryer.
So you're measuring oxygen in the hydrogen output here?
Before the dryer and after the dryer.
Okay.
So before the dryer, just to tell you, like you have so much oxygen, you need to set up your dryer on this level to achieve that final product based on the specifications. You know, the produced hydrogen can have different grades. Those grades are defined by the dedicated ISO standard. This dedicated ISO standard is putting like 4 or 5 different categories from A to D.
Yeah, exactly. Like
it has
certain
different
hydrogen for certain applications.
Exactly.
So like your vehicles would work at according to GAE and so on.
For grade A, for an example, 98% purity is allowed, while grade D will be 99.7, which is 300 ppm of impurities. Out of these 300 ppm, oxygen and moisture are one of the impurities.
So and these you measure
are,
here.
Again, allowed to be present up to certain concentration, and we are looking at that. These are met.
Now, in as much as we are looking at the values and we have these regulations and so on, how does this guy actually find out what the value is? How does it work? Take us deeply into this, please.
So binary gas analyzer, it uses the thermal conductivity.
Yeah.
Thermal conductivity is the capability of certain gas to take away heat,
Yes.
to absorb the heat and take it. And this physical property we use for coming to the content.
Yes. Yeah.
The cell, which is based here inside,
Yes.
and then the electronics, you have the sample gas inlet and gas outlet.
Okay. So there's gas going in and out.
Gas going out.
Essentially, it goes through this thing here. Okay.
So
okay.
we're
And
talking
then
about
on the inside. We see what's
exactly
here on the diagram.
continuous measurement. It's not
Continuous,
just random checks. Continuous measurement. That's why it's important that you have stable, reliable technology that's used in the background. And thermal conductivity is one of the most stable for doing this task.
So we see here the gas inlet, just like we saw on
Exactly.
the gas coming in here. Yeah.
This what we see is the measurement cell. Inside the measurement cell, we have two chambers. One is the reference chamber, which is closed, and then we have another one that is a flow-through chamber. That's the flow-through chamber.
Okay.
Inside, then we have two heating elements, or measurement elements, we can call them. They are kept at constant temperature. Now, if you can see on the right side, I have the scale of, first I have the thermal conductivity, and then I have the relative thermal conductivity to air.
Yes.
And you can see hydrogen, even helium, are pretty far away from the other gases. That means that we can distinguish them well, and we can...
So we see very high values
Exactly.
here, and as opposed to CO2, for example.
Exactly. So how do we come from that specification, from that physical property to the concentration? When the gas coming into this chamber contains some gas, hydrogen in our case, that has higher thermal conductivity than the gas in the reference chamber. Reference chamber is filled with ambient air. Then this heating element, heating a metal wire or thermistor, will reduce the temperature. This temperature is directly related to the concentration of that gas. Basically, both heating elements are connected to a Wheatstone bridge, resistance bridge. We will measure the difference in resistance. We will apply voltage, and that's when we calibrate with known concentrations. So how we come to the concentration.
So that's how we'll know this guy is exposed, so his resistance will change, and then the comparison between two. Interesting. Okay, moving on, I would say to this one. It was
moisture.
Moisture. Yeah.
When we were talking about this one, I mentioned it's a percent level analyzer, low percent level. So we're looking at the very low concentrations of hydrogen leakage or oxygen leakage on the either side of the membrane. With this one, we can measure much lower. We can go down to parts per billion by volume, from ambient down to. So it's a moisture transmitter based on the aluminum oxide technology.
Okay.
So how does it work? You can see here on the drawing, we have the three different layers. Basically, the sensing element consists of three different layers. We have the metal base, and then we have the aluminum oxide, the measurement layer, basically, and then we have on the top, we have another, like a membrane. You can understand it. So like a membrane, another coating.
Which side is exposed to the medium?
The top one.
The top side. Okay.
So
this is the measuring medium on this side, and then we're seeing them. Okay.
So we measure here with this technology. We measure in gases as well as in liquids. So now imagine that the sample containing water molecules flowing past this sensor will immediately permeate, will penetrate, will migrate through the first layer, and will reach the second measurement layer. Adsorption is happening. Adsorption, you can understand, is kind of like a microcondensation on that measurement layer. This microcondensation will change the electrical property of the aluminum oxide.
Of this aluminum oxide. Okay, so it conducts more or less.
Exactly. And then if we calibrate the sensor to known concentrations, we can measure the moisture content.
Is this used up, or this can work forever?
This can work forever. Now and then you will obviously have to calibrate it because you know, like a verification process.
I see. It has measured something.
It shows the moisture content in the room. Now I have set the display to show it on ppv, parts per million by volume.
By volume, okay.
So it's pretty low moisture in the room.
Okay.
And we have also temperature sensor and pressure, ambient pressure.
Okay.
So.
Right, and this one over here?
That's the smallest one, but it's a very capable device. It uses, we measure oxygen impurities in the produced hydrogen with it.
Oxygen impurities. Okay.
Oxygen impurities, because, you know,
Yeah, so oxygen is, on the hydrogen side, oxygen is considered as an impurity.
it's an impurity. You know, like,
okay.
let's say, the very pure hydrogen that it's allowed to be used in the PEM fuel cells for road vehicles. The highest concentration allowed on moisture and oxygen are 5 ppm. So that's the set level, the threshold, so to say, that we are monitoring with both devices, with the moisture one, with the oxygen.
How does this guy know how much oxygen there is?
So when we talk about the electrolysis, we are converting the electrical energy to chemical. And this one, we use the principle, the opposite principle. From chemical energy that the oxygen brings, we convert it to electrical signal.
Oh, that's a fuel cell.
Yeah, it's a fuel cell. Yeah.
Okay.
So in that regard, we are converting that oxygen. You can see here on the
so
drawing.
we have a diagram here.
This is the cell.
Okay. So this thing is actually a mini fuel cell.
Yeah,
in there,
it's inside.
So this is the bottom. This is this bottom part essentially that's shown here.
You can look at it as two partial reactions. The oxygen comes from the bottom, and it will be converted to hydrogen. That hydroxide.
Yeah.
That hydroxide will reach the anode. Anode is made out of a pure metal anode, in our case lead.
Yes.
So the oxygen will. That's the second reaction, is the oxidation. So on the cathode, we have reduction, on the anode, the oxidation.
Okay.
At the very final reaction, 4 electrons will be released. And this is like directly proportional to the oxygen content. It means that the rate of oxygen consumption is directly proportional to.
So the more this one is producing electricity, the more oxygen is present.
Exactly, and we capture the signal like in from 4 to 20 milliamps.
Okay, and this can run forever as well, like the other one.
This is like we said, galvanic fuel cell.
Yes.
Fuel cell. It has certain charge, like the battery for the flashlight. Obviously, at some point, the anode. And the anode is the only consuming part in this, will at some point get consumed. Everything will be converted to lead oxide.
Okay.
Then we need to replace it.
Okay. But it probably has some kind of mechanism to say.
Everything is integrated inside. Okay. So I would say 12 to 16 months, especially for this concentration range. You know, higher the concentration range that you measure, this device can also measure up to 100%. But if you measure in the very low concentration range, then it can last much longer.
Can you then measure the oxygen concentration here in the room?
I do already have one set up that measures the content in this room. We can go over to that one.
Let's move it over. I'm just make some space here. Yeah. Okay. Let's see. I hope we can see this. If we look into the system. So what do we have here?
Now we have the OxyIQ.
Yeah, we have the same
galvanic fuel cell analyzer. We have
there.
integrated it into a sample conditioning system. Sample conditioning system, very important.
This is a sample conditioning.
You can see here, we are displaying the oxygen here, 20.8.
So we have 20.8%
oxygen in the room.
So that's perfect. Those are perfect values.
20.9. So a little bit. I think we should open the window to get some more fresh oxygen here. But I think still in the allowed ranges.
Okay.
Why we need to have this?
Yes.
We need to condition the samples to the technology, to the measurement.
Yes.
The sample, the process gas, might have high pressure, right? But the high pressure is not good for the fuel cell. We need to reduce it to allowed levels.
The fuel cell at the bottom of this.
It's here inside.
Exactly.
It's here inside.
Okay, so it needs to be reduced. Where's the gas coming in?
From this side. That's the sample inlet. And then we have the 3-valve here. That's open. Then we have the pressure regulator. We regulate with that. Before we start, the first thing we close this one. Then we regulate the pressure, look at the pressure gauge, so that the pressure is the maximum set here. 400 psig or 27.5 bar G. That's like overpressure, I would say. And then after we open, we adjust the pressure here. That's the second door we need to open, so to say. That's a needle valve. When we open this needle valve, we look at the flow meter that the flow rate is about 30 liters per hour. This is a standard liter per hour, and this is the standard cubic feet per hour. And another item that we have is this filtering, particle filter. That is filtering particles out if they are
there
present.
needs to be a filter before so as not to destroy the...
Exactly. So this is like a plug and play that you can just put in and turn it on.
So you actually connect the two ends of the gas
basically
there, and then you can work with this directly in your plant. Okay. Very interesting. So this whole setup is needed to make this work properly.
Especially, I mean, we don't know what the process gas conditions are. If we have 10 bar, we need to put them down to what the technology requires. The same setup we will have for this device and also for the binary gas analyzer, because all the technologies, they have certain requirements. And we talk about continuous measurement. So,
and you have this in a box. Why is this in a box?
Stainless steel box, intrinsically safe.
So this
environmental protection.
Environmental protection. Okay. Yeah, and this can
because this kind of system solutions are not used just only in the electrolyzer space. It can be used also in the nitrogen, in the natural gas space, where we are blending, for an example, with the hydrogen. So.
Wow, this is interesting. So, and last question, this guy, so obviously we see the value here. How does it send this 20.8%? I mean, we see it nice and digital here, but like, what interfaces are we talking about? Is it both connected?
4 to 20 milliamp signal will be received,
Okay, it would send that signal out, and then you would need to process that again. Well, this has been very interesting. I mean, we're just going along this whole chain, knowing about the impurities, and also realizing that we have over 20% oxygen in the room here, which is good news for us. We don't know how your oxygen levels are watching this video, but we hope they are good. If you like it, please subscribe or give us a like in any other way. If you're looking for components like these or many other things that you need in the hydrogen economy, whether measuring or other kinds, on highfinder.com you will find lots of them. You can contact Alex and other people like that there. Leave us a note on LinkedIn if you will, and also feel free to enjoy any other video that we make in this series to understand what's really going on. Alex, you've done a great job helping us to understand how this guy knows what he sees, this one and this one as well. Thank you very much for coming.
Thank you also. Thanks for having me. And
thank you for watching. Have a lovely day further.
Thank you.